Welcome to NJP Online Mathematics. Let's solve this lovely Oxford Mathematics here together. We are asked to find all the values of x to satisfy this equation here. So we are given x minus 1 all squared minus 2 all squared minus 3 all squared equals 4. So we should find all the values of x. So let's give the solution to the problem. So we are given that x minus 1 all squared minus 2 all squared minus 3 all squared equals 4. So we have to let x minus 1 equals a. If we let x minus 1 equals a, then substitute it here. We are having that a square minus 2. So let's let the whole of this in this second bracket here equals b, and if we also substitute it there, we are having that b square. We are having that b square minus 3 equals c, and finally we are having that c square equals 4. This becomes the initial equation, this is the second, while this is the third equation. So let's continue with the simplification. So we have gotten that c square equals 4. So since this c square equals 4 and 4 is a perfect square, that is 2 raised to the power of 2 equals 4. So we are having c square minus 4 equals 0. Since this is this, we are having c square minus 2 square equals 0. So let's give the relationship for the difference of 2 square. If we are having a square minus b square, that this here can also be written as a square minus ab plus ab minus b square. So if we now group them, we are having that a is common to a minus b plus b into a minus b, and this is a plus b multiplying a minus b. So we have to remember this relationship because we'll be using it more often to solve this problem. So this relationship for the difference of 2 square, we have to apply it here. So if we apply it here, when c is now the a and 2 becomes the b, so now we are having c plus 2 or multiplying c minus 2 equals 0. So since this equals 0, it's either c plus 2 equals 0 or c minus 2 equals 0. Therefore, c equals negative 2 or c equals a positive 2. Therefore, the values of c equals positive or negative 2. Please, let's remember this. This has been the first answer we have obtained, but this is for the value of c. We have to continue by substituting the values of c now into equation 3. So let's continue to substitute the values of c here into equation 3. So let's substitute when the value of c equals negative 2. So if the value of c equals negative 2 and we are substituting into the equation that b square minus 3 equals c, then b square minus 3 equals negative 2. Then b square minus 3 plus 2 equals 0. Remember, we are taking the negative 2 from the right hand side to the left hand side, and we are having this. So this becomes b square minus 1 equals 0. And 1 can also be written as 1 square. So we are having b square minus 1 square equals 0. Remember the relationship for the difference of 2 square here. We have to apply it here. So then we are having that b plus 1 or multiplying b minus 1 equals 0. And it's either b plus 1 equals 0 or b minus 1 equals 0. So b equals negative 1 or b equals a positive 1. Therefore, the values of b equals positive or negative 1. We have now obtained the second value for b only when we substituted that the value of c is negative 2. So now let's substitute when the value of c equals a positive 2. So if we substitute when the values of c, when c equals a positive 2 now, because we've substituted when it's a negative 2, when it's a positive 2. So we are having in the equation that b square minus 3 equals c. Therefore, b square minus 3 equals 2. Therefore, b square minus 3 minus 2 equals 0, and b square minus 5 equals 0. This 5 can also be written as, if we have a number a, that a raised to the power of 1 is still the same thing as a raised to the power of 2 divided by 2. And we can continue to write this as a raised to the power of 2, and these 2 at the exponent is multiplying 1 over 2, and this can also be written as a raised to the power of 1 over 2. This 1 over 2 at the exponent is still multiplying 2. So we can apply that here, and we are having b square minus 5 raised to the power of 1 over 2, or multiplying 2. And we know that this is the same thing as the root of a. So let's apply this here. So we are having root 5 here. B square minus root 5 all squared equals 0. So if we now apply this difference of 2 square relationship here, we are having b plus root 5 or multiplying b minus root 5 equals 0. And it's either b equals a negative root 5 or b equals positive root 5. Therefore, the values of b equals positive or negative root 5. This is now the second values of b that we have obtained. We obtained the first positive or negative 1. Now we've obtained positive or negative root 5. So since we have now obtained the two values of b only when we substituted when c equals positive 2 and when c equals negative 2, now we have to substitute in the next equation that we are having there, which is equation 2, when a square minus 2 equals b. So a square, we are having in the second equation that a square minus 2 equals b. So now let's substitute when b equals negative 1. Then we are having a square minus 2 equals negative 1, and that a square minus 2 plus 1 equals 0, and a square minus 1 equals 0, and 1 is a perfect square, so we can write a square minus 1 square equals 0. So these two, we can still apply this relationship here. So we are having a plus 1 or multiplying a minus 1 equals 0, and a plus 1 equals 0, or a minus 1 equals 0. Therefore, we can now see that a equals negative 1 or a equals positive 1. Therefore, our values of a equals positive or negative 1. Now we have obtained the value for a when we substituted when the value of b is a negative 1. Please take note that whenever we are substituting the values of each of the variable when it's a negative 1, that we continue to have a positive or negative 1. So we've just substituted when a is a negative 1. So now let's substitute when b is a positive 1. When b is a positive 1, we are now having in the equation that a square minus 2 equals b. And b now is a positive 1. So we are having a square minus 2 minus 1 equals 0. And this becomes a square minus 3 equals 0. And we can still apply what we did here, and we are having a square minus root 3 all squared equals 0. And we are having that a plus root 3 or multiplying a minus root 3 equals 0. And it's either a plus root 3 equals 0 or a minus root 3 equals 0. So for this to take place, then we are having that a equals negative root 3 or a equals a positive root 3. So if a equals a negative root 3 and b equals positive root 3, then the values of a equals positive or negative root 3. So we have now obtained another value for a. We have obtained two values for a now in the equation. We have obtained two values for a. Remember, this is the first value of a, and this is now the second value of a, only when b is a positive or negative 1. We've not substituted when b equals positive or negative root 5. So let's substitute when b equals negative root 5. If we now substitute when b equals a negative root 5 into the equation, a square minus 2 equals b. And then a square minus 2 equals negative root 5. And a square equals, we have to take this to the other side, and we are having 2 minus root 5. And then a equals positive or negative root 2 minus root 5. A equals positive or negative this minus root 5. And so we have to find the value of root 5 here. And the value of root 5, we can say a equals positive or negative the root of 2 minus 2.236. 2.236 is the value of root 5 here if we use our calculator. So this minus this, we can see that this is positive or negative the root of negative 0.236. So since we are having a negative with it, if we are having this negative sign with it, we can continue that this is the same thing as a equals positive or negative root of 0.236 multiplying the root of negative 1, and the root of 0.236 here is positive or negative 0.4858, and the root of -1 here is I. So we are having positive on negative. This is 0.4858 I. This is the iterative value of when we determine the root of a -1. So this is what we are now having as the value of A, that A equals a positive or negative the square root. A equals positive or negative 0.485 I. So this is another value of A. We have obtained the first, the second, the third. So now that's when the value of A equals a negative root 5. So let's substitute when the value of B, remember we are now here, equals a positive root 5. So into this equation, that's A square minus 2 equals root 5. So we are having that A square equals 2 plus root 5, and we are now going to find the square root of both sides. We are having positive or negative 2 plus root 5, and this is for the value of A, and this is 2, the root of positive or negative 2 plus 2.236. So this is the value that we have obtained, and this equals this positive or negative the square root of 4.236. So this now becomes the value of A. So we have to find the square root, and if we find the square root, we are having 2 points, positive or negative 2.056. 2.056 as the value of A. We have now obtained another value of A in the equation. Now we have obtained 4 values of A. The first is when A is positive or negative 1. The second is when A equals positive or negative root 3. The third is when A has an iterative value of 0.48 I, and A equals positive or negative the root of 2.056. This is now 4 values of A, which we can substitute here into equation 1. So since we have obtained the 4 values of A, that's only when is root positive or negative root 5. So we are done substituting the values of B. Now let's substitute the value of A now. The first value of A here. So this is the first value of A. We are now substituting when A equals -1 into the initial equation that we are having, that x minus 1 equals A. So x minus 1 equals A, and we are to find the value of x. So we are having that x minus 1 equals -1, and now we are making x the subject. We are having -1 plus 1, and this is equal to 0. Therefore, we have now obtained the first value of x to satisfy this equation that we are having here. So since we have now obtained the first value of x, this is x equals 0. This is the first value of x. So now it's after the substitution when A equals -1. So let's substitute when A equals a positive 1. When A equals a positive 1. When A equals positive 1. So into this equation, that x minus 1 equals A. So we are having that x minus 1 equals A, and now A is positive 1. So we are having that x equals 1, and when it goes to this side, it becomes plus 1 and x equals 2. So we have now obtained the second value, that x equals 2. This is now the second value. So now this is when a equals positive 1 or when a equals negative 1. So we have to substitute the next value when a equals a positive root 3 or when a equals a negative root 3. So let's substitute when a equals positive root 3 into this equation. Then we are having that x minus 1 equals root 3 and x equals 1 plus root 3. So we have now obtained that the value of x equals 1 plus root 3. So if we use our calculator to find the value of root 3, we are having that is 1 plus 1.732 as the value of root 3 there. So we are now having that x equals 2.732. So we have obtained another value of x, that is 2.732. This is another value of x. So now let's substitute when a, remember, is when it's positive, now 1 when it's negative root 3, and a is negative root 3. We are having that x minus 1 equals negative root 3, then x equals 1 minus root 3, and this is 1 minus 1.732, and this is negative 0.732. This is another value of x that we have just obtained. This is another value of x. So now we have to say that x equals negative 0.732. This is the fourth value of x. This is only when x is this. A is positive or negative root 3. Please recall that we also said the value of a is positive or negative 0.4858i. So let's still substitute. We have to substitute now. When a equals positive or negative 0.4858i. So remember, when a equals 4858i, into the equation x minus 1 equals 0.4858i, and then we are having that x equals 1 plus 0.4858i. So this becomes another value of x, that x equals 1 plus 0.4858i, or x equals 1 minus 0.4858i. So we have obtained 6 values of x. We don't know which of the value of x is an extraneous value of x or which will satisfy the equation. So now we have to substitute finally the last value of a into this equation here. So we are having that a equals positive or negative 2.0.56. So when x a equals positive 2.056, then x minus 1 equals 2.056, and this x equals 2.056 plus 1, and we're having that x equals 3.056. So x equals 3.056. That's another value of x that we have now obtained. So we still have to continue. Let's substitute when x equals a negative 2.056. So when a equals a negative 2.056, So when a equals a negative 2.056, then x minus 1 equals negative 2.056. So x equals 1 minus 2.056. So this is equal to a negative 1.056. So the value of x here equals negative 1.056. So we have now obtained 1, 2, 3, 4, 5, 6, 7, 8 values of x to satisfy the initial equation that we have. So let's see whether each of the value of x here can satisfy the equation that we are having by substituting and checking if it will actually become the value of x to satisfy the equation. So we are having the first, that x equals 0. So if we see in the equation, we are having x minus 1 to power 2 minus 2 to power 2 minus 3 to power 2 equals 4. So if we substitute when x equals 0, then we'll be having that this is minus 1 and minus 0 minus 1 and it's minus 1. If we square it, we're having a positive 1. If we subtract 1 from 2 from the 1, we are having a negative 1. If we still square it, remember we are having 0 and 0 minus 1 is minus 1. We square the minus 1, we'll be having a positive 1. If we remove 2 from the number, we are having minus 1. If we then square it, we are having a positive 1. If we subtract 3 from the 1, then we will be having a negative 2. If we square negative 2, then we'll be having a positive 2. Therefore, the value of x is 0. 0 can satisfy the problem. So now let's substitute when x is 2. If we see that here we are having x minus 1. So 2 minus 1 is 1. If we square it, we are having 1. Subtract 2 from the 1, we are having a negative 1. We also square it, we are having 1. And 1 minus 3 is a negative 2. And if we square it, we are having 4. So 2 can also be the value of x to satisfy the equation. So we have obtained this, that this can really satisfy our equation here. So now we have to substitute when x is 2.732. So if we approximate this to the nearest whole number, then we are having that x equals 3. And if we see in the equation here, if we substitute the value of x, which is 3, into this equation, then here we'll be having 2, and 2 square is 4. 4 minus 2 is 2, and 2 square is 4, and 4 minus 3 is 1, and 1 square is 1, which is not equal to 4. Therefore, this value of x cannot satisfy the equation. This cannot satisfy the equation. This cannot really satisfy the equation. So we have only obtained 2 values. Now let's see for this. If we approximate it to the nearest whole number, then we are having negative 1. So if we substitute negative 1 into the equation that we are having here, that x minus 1 square minus 2 square minus 3 square equals 4, then we'll be having minus 1, that is a negative 2. 2 square is 4, and if we remove 2 from the 4, we are having 2. We square it, we are having 4. 4 minus 3 is 1, and 1 square is 1, which is not equal to 4. Therefore, this value of x cannot as well satisfy our equation that we are having there. This value of x, that x is 0.732, cannot satisfy x. So let's continue. If we see that this has illustrative values. Since these have illustrative values, if we substitute these two, let's take that x is this. If we substitute this into this, our equation here, if we substitute when x is 1 plus this, and we remove 1 from it, then we are having this, the whole of this. We are having the whole of this all squared. So this square, when we square it, then the -1 with it is gone. So we are having, this will be gone and will not have this any longer. So we'll be having 0.236 minus 2. Then we'll be having 1.8 something as the value here. And if we square it, 1.8 something, and if we approximate it to the nearest whole number, then it equals 2, and 2 square is 4, 4 minus 3 is 1, and 1 square is 4. So this cannot also as well satisfy the value of x, and since this cannot satisfy the value of x in the equation, this cannot as well satisfy our original value of x. So let's see when x equals 3.056, when x equals 3.056 here, when x equals 3.056, if we remove 1 from it here, we'll be having 2.056, approximately 3 here. So if we remove 1 from it, we are having 2, and we've just done that here. So 2 square is 4, 4 minus 2 is 2, 2 square is 4. So if we remove 3 from it, we are having 1, 1 square is 1, which is not equal to 4. Therefore, this cannot satisfy our value of x. Take note, all these values have not satisfied our value of x. We are only having that x equals 0 or x equals 2. So let's see whether the final solution of x will satisfy the equation that we are having here. We are having that x equals negative 1.056. So this is approximately -1. So if we substitute the -1 into the equation there, then we are having -2 in this first bracket. If we square it, we are having 4, and 4 minus 2 equals 2, and if we square it, we are having 4. 4 minus 3 equals 1, and 1 square is 1, which is not equal to 4. Therefore, these two cannot satisfy our equation. So we are only having the values of x to be 0 and 2 respectively, which can satisfy our equation. Therefore, our values of x equals 0 and 2 that can satisfy this equation. So the number of our real values for x which can satisfy our original equation that we are given, that x minus 1 all squared minus 2 all squared minus 3 all squared equals 4, are 0 and 2. Thank you for watching. Kindly like and subscribe.